So I also want to re-emphasize the warming aspects and also look at the patterns of warming, right? Just like sea level, warming also is going to be non-uniform because we still have the weather and climate happening and transporting energy. Remember, we still have the Walker cell, El Nino, monsoon. We still have the Hadley cell. They're trying to move the energy. We're changing the equator to pole temperature gradient, but energy doesn't simply follow directly. It goes through zonal and meridional circulations. And there are dynamics. The monsoon dynamics creates certain conditions in the Indian Ocean versus the Pacific. We will look at features in each ocean. Um, there are dynamic reasons why they will look different. Some regions are more sensitive to greenhouse gas warming than others, so this matters, right? Nonetheless, we keep looking at this global mean temperature rise, which is a useful metric, of course, because it gives you a pulse on how the global mean CO2, which is easily measured, is affecting the global mean temperature. Right? That's what we talked about. So here is the smoothed out CO2 that has reached 415.39, and by now it will be already beyond that. And the temperature that started as below the modern period baseline to warming and cooling during the Second World War and after. And since the mid-1970s, as CO2 increase has accelerated, it's not only increasing, but the increase has accelerated with more economic activities, more development, more economic growth and deforestation, land use change, agriculture, transportation, and so on, right? Temperature has continued to have these year-to-year ups and downs because natural variability like El Nino and monsoon are still there. But you can see, as we saw before, that the decades are getting warmer and warmer. So here we have the 1970s. So we had the before 1930s or so, cooler than the base period of 1961 to 1990. Flipped to the warmer side in the 1940s, 1950s. There are some data issues here, but people take great care to fix the problems and define the uncertainties. It's not like you can fix everything, but you can estimate how uncertain you are, like the confidence we talked about before, right? 1970s, 80s, 90s, 2000s, and the last decade, 2010s. We're now in 20, so we are getting into the new decade. You can see that each decade is warmer than the one before. So we have reaching close to 1.5 degrees of anomalies with respect to this period. This is not good news, but we will look at it in another way. So this is supposed to be, and there we go. So this is showing how the global mean temperatures have increased. This is basically the same thing depicting a different way of doing this. So you started with lots of blues, you started getting into warmer colors, yellows, and then soon you will get into reds if you don't stop doing what we are doing, right? So this is going to 2017. It will be updated constantly. You can find it on Google. Okay, I think I have the website in there. So it's based on a temperature data set called HAD-CRUT, which is developed by I think East Anglia and the Hadley Center. You can look it up. Nonetheless, this is a different way of depicting it. We are getting warmer and warmer and warmer. This is the next one is good because this shows the patterns of warming. So it's showing every 5 years starting in 1880. So 1880 to 1884. When we looked at the global mean, we said the decadal temperatures and the yearly temperatures were below the long-term average. But here you can see that there were already some places that were warmer, like Africa, North Pacific, parts of the Arctic, North Pacific here, and parts of the Southern Ocean, and so on. So this was just the beginning. We were already into the Industrial Revolution. Little Ice Age was hiccuping to an end. As I said, it could have been accelerated by the industrial activity. It could have been naturally transitioning out, but industrial activity, especially the soot in the snow and glaciers, would have probably accelerated the melt rates. Okay, so let me run this and watch it, how the colors go from lots of blue into basically lots of red. Okay, that's what you have to watch out for. So here we go. Each 5-year period, it's a moving window, so you keep moving the window by 5 years, and you can see that there are dynamics which determine the regional patterns. So it's not enough to just say that global warming is happening. Ultimately, let's say a country like India or Egypt or whatever country you pick, why not US, right? They want to know what's happening in their backyard, because nobody lives in the global mean temperature, right? Nobody does. So we need to know how the warming is happening in our neighborhood, as local as possible, because all global warming is local. If nothing changes in my neighborhood, why would I worry about global warming? Correct? And look at the last 5 years. Okay, you have the cool pattern here, and the warming is less in the tropics compared to the high latitudes. The data is an issue in the Southern Ocean because if you remember, you had the 40s, roaring 40s, furious 50s, and screaming 60s, very stormy region in the Southern Ocean. So I said most of the data gets collected during the summer months. Nobody wants to go there in the winter. In fact, it's banned because you cannot even be rescued if you're in a ship and you got hammered by a storm. People get stuck on Antarctica, but they are supposed to be ready to live through the winter. There are medical emergencies and evacuations cannot be done, so all kinds of things happen. Nonetheless, the data uncertainty is higher here, so we will see why the polar regions are warming faster, but you already have an idea why. Ice albedo feedback. And what is special about this region? Okay, think about it as I play this again. Lots of blues with some reds here and there, but slowly over time we are still mostly in the Industrial Revolution, increasing emissions, accumulating carbon, increasing industrial activities, etc. But as we get into the 60s and 70s, the blues begin to disappear and we become all red all over. Okay, so now you can see we are pretty much red everywhere. What is special about this region again? This is where our deep water formation is happening, here in this region, right? Now you remember your movie Day After Tomorrow, right? So if you change the freshwater input here, you will change the density heavy water formation and the deep water formation. That affects the heat transport by the Gulf Stream and so on. There are also other processes happening. So this is a study area that's very of great interest, but obviously it is partly at least related to the deep water formation and the meridional overturning circulation, or the global thermohaline conveyor belt that we talked about, right? Remember, deep water forms here, here, comes up in the Indian and Pacific Oceans, comes through the Indonesian through flow around Africa back to this region, right? So this is why I wanted to show this again, to make a few more points. So global warming is not uniform, which also means that global warming will create winners and losers. For example, if Siberia warms and all the snow disappears and it becomes very favorable for agriculture, maybe they will be the richest people in the world by growing lots of wheat or cotton or whatever cash crop, sugar cane, and export it to the world. So would they care about global warming? These are real issues. Who is going to pay the price? Who's going to suffer and who's going to benefit?